We are going to be using circular motion to derive the relationship between linear motion and angular speed. This is the angular, this is the definition of angular, and this is linear. So let's look at the diagram. From the diagram above, we discover that as the object begins to revolve around the circle, the angle keeps changing and the radius keep moving. Now, as it moves from this point down to this point, it's got the distance s increases. So it means from the diagram, s is equal to r root theta, because as the angle increases and the radius changes, s also increases. So x is equal to r root theta. Another thing you should know is that velocity is given as distance over time, okay, speed over time. Now, for here we are dealing with angular velocity and it is denoted as this angular velocity. Now, what is changing here is not distance. What is changing here for an angular velocity is theta. So we're going to see it's going to be theta over time. So the angle changes with time. Now, from our equation, this equation and this equation, we are going to be doing some things with this equation. Now let's consider this. From v, which is distance over time, we discover that from this equation 1, let's put this as equation 1, this as 2, and this as 3. S is given as r root theta, but S is given as r root theta from the diagram above, okay, as from the diagram above. So where we see S, we put in r root theta. So velocity becomes r root theta over t. Now, velocity can also be rewritten as r root the radius multiplied by theta over time. Now, this is the same thing as this. Now, you should not forget that w is given as theta over time. So, from here, v equal to r root multiplied by, where we see theta over time, we are going to put w. Then we get the equation v is equals to r root w, or you can see write it as v equals to w r. Whichever one you want to write is the same thing. You can easily interchange them. Whichever one you're convenient with, you go ahead with them. Now, another thing you should know is that 1 revolution is equal to theta, okay, and theta is equal to 360, okay, and this 360 is equal to 2 pi. Now, pi is equal to 180 degrees. So 2 multiplied by 180 degrees is giving us 360 degrees. So theta is 2 pi. Now, when we have w, angular speed, equal to theta over t, I can replace theta to be 2 pi over t. Remember, f is equal to 1 over t. So I can rewrite this as 2 pi multiplied by 1 over t. Then I replace 1 over t with f. So w equal to 2 pi f. That is when you have an equation to solve. You should be playing around with all this. So this is what we have for today, the derivation of linear velocity and angular speed. Thank you for watching. If this video is helpful, please like, subscribe, and also share, and also give me a comment. Thank you very much.